Okay, so tomorrow we're going to focus more on scatterplot graphs. These are all examples of scatterplot graphs, and we did these on our calculators today. You can see that we have the x and the y axis. The x is independent and the y is dependent. And we look at the flow of these different scatterplot graphs. X is always the independent and y is always the dependent. That was on your test. Okay? So scatterplot graphs have points that are not connected, and it represents variable pieces of data. So you might want to take a couple quick notes here. The idea of the scatterplot is to show a relationship between two sets of data, meaning one affects the other. The correlation is the relationship between the two variables. The line of best fit, also called the trend line. And again, this has many different names. Sometimes it's just called the linear regression. And I believe you see that mostly on your test. So we've got three names. We've got the line of best fit, the trend line, or the linear regression. And that is a line that represents on the scatter plot. You should be familiar with positive correlation, where the data rises from left to right, negative, where the data goes top to bottom, like a negative slope, and no correlation, and that's where your points are kind of all over the place. There's no definite rise or fall to them. So those are things you need to come into class knowing. The three words for a trend line: positive, negative, no correlation, and the understanding that a scatter plot is made to show a relationship between two variables. So let's look at some relationships. You receive a grade point average and the number of A's you receive. So is that going to have a positive, negative, or no relationship? Well, as your grade point averages increase, so should your grades, so that should be positive. Time spent studying on the test and time grade on your test, again, that should be the same. The more time you spend on the test, the greater your test grade will be. So those are both increasing. The size of the person and the number of fingers he has. Well, hopefully everyone has 10 and your size doesn't matter. So that should be no correlation. The height and weight of each team member of a soccer team. Well, in the grand scheme of things, the taller you are, the more you should weigh. Now that doesn't happen all the time, but generally we say that that should be positive. Both are increasing. The size of the car or truck and the number of miles per gallon. I want you to think about this one and come in with your answer to this one. Would this one have a positive, negative, or no correlation? And kind of be able to explain your reasoning why. So you are to do that one. The number of telephones using the same cell phone and the number of phone calls you receive. Again, I want you to come up with the answer for this one on your own. Positive, negative, none, and why? The speed of a runner and the number of races he wins. That one's easy. All right. So, I'd like you guys to also do these two. The minimum wage and the year. Hopefully you know minimum wage is the very small amount of money that employment is allowed to pay you. So minimum wage means you can't pay somebody under that legally. And two, the amount of precipitation. Hopefully you know that's rain, and the day of the week. So you have 4 of these that you should come in with the answer to tomorrow. So these are examples of different graphs. Obviously these are positive slope. They rise right to left. This is all over the place, so this is no correlation. This is top to bottom. Now you can tell the difference between these two. These are all nice and tight around the trend line, and these are sort of scattered. So we called this one a strong fit. And then this is a weak fit. It's positive, but barely. And we do the same thing for the negative. This would be a weak negative, and this would be a strong negative, because those points are nice and tight, close to the trend line. So just as I just said. Okay, so we're going to do some more with putting in our line 1, line 2, and calculating relationships. But tomorrow we're going to look at what's called the R value. And so this may not come up right away in your calculator, and I'm going to show you how to make the R value come up tomorrow. But we want to look at the R value, and the R value is the correlation coefficient. And that is tells you how strongly your X and Y axis are related, how strongly the time studying to the grade on your test is related. R squared is something we're going to look at a little bit later when we get into matching up the right function with the right graph. So you might want to write this little chart down because you'll need it tomorrow. I know my head's in the way, so I'll move it up in just a second here. So if your R is 1, that's very strong. That means just like we just showed here, this would be have an R factor of 1. It's very strong. So this would have an R equals 1. This would have an R equals of 0.5. It's weak. It's not real close. 1 is the highest you can get. And this would have an R factor of 0, meaning the X and Y aren't related at all. So that would be like our height and our number of fingers. They're not related, okay? Now this is negative and weak. So just like this was positive and weak, we'd have an R equals a negative 0.5. And this is very strong, so that should be R equals 1. Now, you don't find very often that things are exactly 1, sometimes. But even if they're like a 0.99 or something like that, that would be a strong one. Okay, so it doesn't have to necessarily be 1, but if it's very close to 1, you still call it strong. And then anything really in around half is weak. There's a small correlation, but not much. And this means those two X and Y axes aren't related at all. And then we have the same thing for when you have a negative, like one is increasing, the other is decreasing. So hopefully my head's not in the way here. But really, all you need to know is this part right here, the R and the correlation. So take a minute, copy that down. Okay, and after you get that copied down, tomorrow we're going to spend some time trying to find a thief. There's a thief in our room. It could be me, or it could be you. But we're going to use Scatterplots to find out who this thief is based on our evidence. So it's me, or it could be you. We'll find out tomorrow.